This video is for ELEC 2132, Circuit Analysis 1, and this video is about an introduction to diodes. Just for a little bit of context, this course is generally about linear circuits. And when we say linear circuits, we mean circuits that behave according to the equation f of a times x plus b times y equals a times f of x plus b times f of y. So an equation that behaves according to this rule, for example, is V equals IR. We could say that the voltage is a function of the resistance. So, for example, if I have two resistors in series, I'll call the resistors both resistance R, and I will say that the voltage across either resistance is V sub R. Now, f of x is going to be the voltage as a function of the resistance. Function of a times x means that I'm multiplying the resistance by a constant, possibly adding two of the resistors in series. That means that I'm going to get in total double the voltage, 2V sub R, which means that I can either calculate the voltage for one resistance and multiply that by 2, or combine the resistors in series and then ultimately get the same result, which would be A times f of x. The second scenario is when I add two resistors of unequal values together, R1 and R2. Now, if I want to know the total voltage, V sub x, across these two resistors, I can either calculate the voltages independently, V sub 1 and V sub 2, which would mean that I'm adding an f of x and an f of y together, say V sub R1 and V sub R2, or I can combine the resistors into an R equivalent, and that will give me right away V sub x. Combining the resistors into R equivalent would be V of R1 plus R2. So because these two equations are equivalent, and because it worked for two equal valued resistors, which is equal to multiplying the resistor value by a constant, this equation behaves linearly. So most of the circuit elements that we're going to deal with in this class are linear circuit elements. However, diodes are nonlinear. They don't behave like resistors, they don't behave like capacitors, they don't behave like inductors. So you can't combine them in the same way. Their behavior is generally pretty different from resistors, and they're not quite as subject to equations as resistors are. Just to go into the theory a little bit, diodes are constructed of something called a p-n junction. That is a mix of semiconductors that creates some kind of unusual behavior. Diodes are also directional, which means that they have an orientation associated with them, and you have to be careful about the orientation. So we name each of the terminals. The positive end is called the anode, and the negative end is called the cathode. The diode symbol looks like this, where the anode is connected to the flat end of the triangle. The cathode is connected to a horizontal line connected to the point of the triangle. Now, the reason why we're interested in using nonlinear circuit elements in a linear circuits class is because LEDs are diodes, light-emitting diodes. LEDs are very useful to us because we can make really interesting projects using LEDs. The ideal diode model is a relationship between current and voltage for a diode. The voltage is going to be defined as the difference between the anode voltage and the cathode voltage. When that is below a threshold, V sub threshold, the current is going to be 0, and that even holds true for voltages less than 0. When the voltage is above that threshold, the current can jump up to infinite. So what that basically means is that below the threshold voltage, the resistance is infinite because there's no current being pulled, and above the threshold voltage, the resistance is 0. So there are really two states in the ideal diode model. The first state is when V anode minus V cathode is less than the threshold voltage, and that's referred to as the off state. In the off state, the diode acts like an open circuit, which means that its resistance is infinite. When the anode voltage minus the cathode voltage is greater than or equal to the threshold voltage, we say that the diode is in the on state, and the diode acts like a voltage source with value threshold voltage. The threshold voltage is usually around 0.7 volts. For some LEDs, the threshold voltage is higher, maybe as high as 2.1 volts. Generally, 0.7 volts is used in most academic examples. All right, so let's look at how the diode would actually behave in some example circuits. So let's say that I have a voltage source of value 3 volts and a diode connected with the anode to the negative end of the voltage source and the cathode to the positive end of the voltage source. Well, right now, the anode voltage minus the cathode voltage is negative 3 volts, and if the threshold voltage is 0.7 volts, V anode minus V cathode is less than that, so the diode is off, and we say that this is an open circuit with no current. So let's also say maybe that I have a voltage source with value 0.5 volts, and now the difference between the anode and the cathode voltage is 0.5 volts, which is still less than the threshold voltage, meaning that the diode is in the off state and no current is pulled, meaning that its terminals are treated like an open circuit. So now let's say that I have the voltage source with value 3 volts, and now the difference between the anode and the cathode voltage for the diode is 3 volts, which means that the diode is going to start acting like a voltage source with value 0.7 volts. There's something wrong here, which is that we cannot connect two voltage sources in parallel that have different values. When you connect a diode in this way, it will start smoking and burning. Generally, when you connect two voltage sources in a circuit and something is wrong, like you can't connect them together, ideally in a circuit, and you try to do that in real life, something is going to start smoking and burning. So we don't want to do that. In general, you never connect a diode to a voltage source without some series resistance. So let's look at that scenario now. If I have the 3 volt source and let's say a 100 ohm resistor, and then my diode with threshold voltage 0.7 volts, well, the diode is going to be in the on state, which means that it acts like a voltage source with value 0.7 volts. And that means that the voltage difference across the resistor is 2.3 volts. And then the current, which is pulled through this circuit, is going to be equal to 2.3 volts divided by 100 ohms equals 23 milliamps. So there's a lot more that diodes can do and that we use them for, but this is as far as we're going to go as far as material regarding diodes in this class. And so hopefully now you can understand how to bias diodes and how to get the correct current through them. And also you should know never to connect them directly to a voltage source, which will lead to a lot of burning and smoke.